So talking about question number 1. Now question number 1 says find the roots of the following quadratic equations if they exist by the method of completing the square. Now completing the square is nothing but you are just factorizing it, as we have discussed in our video on theory as well. So when you factorize a quadratic expression, or let us say when you are trying to find out the roots of a quadratic equation. Now when I say roots, I am talking about real roots because I am talking about zeros. So zeros, when you are finding out the zeros or when you are factorizing a quadratic expression is when you are trying to make it a perfect square. So in that case, we are already aware of the fact that finding out the roots or factorizing it is just like making a perfect square. So we will be using the same thing that we would have discussed in our videos. Okay. Now when they say find out the roots of the following quadratic equations if they exist, that means, the very first thought that comes to my mind is when they are talking about roots and they have not specified the question as zeros. In that case, what are they talking about? Which type of roots are they talking about? Are they talking about real roots or are they talking about non-real roots, which we call it as imaginary or complex? Okay, so in that case, what do we need to do at the very outset is we just need to write down the values of a, b, c. And then find out the value of delta. So the delta here is, we know that delta is equal to b square minus 4ac, which in this case will be 49 minus 4 into 3, which is, how much is 4 into 3? 12. 12 into 2 is a 24. So we get a 25 in this case. So this means delta is positive, which is why now we are talking about real roots. Roots, for me, if as a student, if I am attempting this question, the word roots, if somebody asks me to find it out, it is ambiguous and I need to make it unambiguous. How do I make it unambiguous? I talk specifically which type of roots are you talking about? Are you talking about real roots or you are talking about imaginary or complex roots? So in this case, in order to determine that, we found out the value of delta, which is the discriminant, which is greater than 0. So we are having real roots. Okay. So can we expand it like this? So if they exist, find the roots. So can we make it as a perfect square? Of course we can. We already know. So how do I make it a perfect square? A times of x plus b by 2a whole square minus root of delta. This is how we make it a perfect square. How we make an equation, a quadratic equation, a perfect square is what we are talking about. Okay. So now can we substitute the values? Of course we can. So how much is the value of a? The value of a is 2. Now x, how much is the value of b? B becomes equal to minus 7 upon 2a, which is 4. How much is the value of root delta? 5. 2a, 4. So can I say the roots are basically, so this is how you square it up. We have already squared it up. Now how do we find out the roots? We know that in order to find out the roots, the value of alpha, so I equate this to a 0, which is just like saying x minus 7 by 4 whole square minus 5 by 4 whole square is equated to a 0. Then we say what? Then we say x minus 7 by 4 whole square. So I take 5 by 4 on the other hand side, 5 by 4 whole square. So the moment I do it like this and I say now let us take the square root on both the sides. So I'll say it is either plus 5 by 4 or minus 5 by 4. Once you have said this, in that case you will say what? Now x is equal to minus 7 by 4 plus 5 by 4, or you will say it is minus 7 by 4 minus 5 by 4. So in either of the case, now here this is minus 2, which becomes minus 1 by 2, or minus 3. Is there a way to check your answer? Yes, you can always check the answer. Now you have the sum. You can always, so it says justify also. I mean, the question does not say, but you can always justify your answer. How do I justify my answer? We know that the sum of the roots. How do I write down the equation having the sum of the roots? So we will say a times, which is 2, sum of the roots, that becomes minus 3 1 by 2, which is minus 7 by 2. So x square minus the sum, which becomes 7 by 2, plus the product of the roots, which becomes 3 by 2, becomes equal to 0. Now, am I getting the same equation? So now the sum of the roots was minus 7 by 2. So we wrote the equation as a times of x square minus the sum of the roots. So this looks to be incorrect. So let us see, where did we do a mistake here? So now what have we done here is, we have taken a times of x plus b by 2a whole square minus, now when we are expanding this, we are basically talking about this expression, right? Okay, so now once we came down to this step and then we said that okay, now we equate both the sides, which we did. So now squaring both the sides, and when you find out the square root on both the sides is what we did here. Now when we had taken 7 by 4 on this side, it was not minus 7 by 4, it was plus 7 by 4. So in one case you get it like this, in the other case. So here, when you're finding out the answer, please try and justify your answer also with the help of the formula. And the formula is, if I know the roots, this is how I write down the equation, quadratic equation, where S is the sum and P is the product. Okay, let's come down to the next question. So coming down to the next question, now here we have A is equal to 2, B is equal to 1 and C is equal to minus 4. Let us find out the value of delta quickly. So which is just like saying, how much is 4 into minus 4? Minus 16 into 2. Minus 16 into 2 is minus 16 into 2 is minus 32. Minus. So and then minus or minus becomes plus. So the value of delta is greater than 0, which means what? It has real roots or zeros. We need not call real zeros, we can just call it as zeros, which means real roots. Okay, once you have this, let us first check this once again, b square minus 4ac, because you are going to get irrational roots. Irrational roots are roots written under the roof of a root. Okay, so b square is 1 minus 4ac is just like saying a plus 32. So you will be getting these. So now once you know that this process of making it a perfect square is nothing but what are we saying here is, we are finding out the roots, the real roots or the zeros as minus b minus root delta upon 2a. So either I write it like this or I can simply use this expression. But when you are solving a question, then you need to establish this before you solve this. Since we have already established, so we are using it directly. Okay, so now we know that this is the expression, equation that we are supposed to use, which is 2 times of x plus b by 2a, which is 1 by 4 whole square minus root of delta, which is root of 33 upon 4 whole square equated to a 0. So now after this you will say x plus 1 by 4 whole square is equal to plus, so this is equal to root of 33 by 4 whole square. So which is just like saying x plus 1 by 4 is equal to minus root 33 by 4 or plus root 33 by 4. So now this, now since we can take 4 as the denominator, now this will be minus 1. So x is just like saying minus 1 minus root 33 upon 4 or minus 1 plus root 33 upon 4. So in this case, the roots are not only real, but they are irrational as well. In this case, the roots are not only real, but they are rational as well. Right? Let's move on to the next question. So we could have used this, which is alpha is equal to minus b minus root delta upon 2a minus b plus root delta by 2a directly, because that is just like you are trying to find the perfect square. So when I talk about the next equation, all I need to do here is a is equal to 4, b is equal to 4 root 3, c is equal to 3, and we just need to find out the value of delta first. So delta is b square minus 4ac, which is just like b square is 16 into 3, which is 48, minus 4 into 3, which is 12 into 4, 48. So the moment you get the value of delta as 0, which you got, so you will say what? Real and equal roots. Real and unequal roots. Real and unequal roots is what you would say in the first and the second. Okay. Once you get this, now simply using the value of alpha and beta, which is just like we are trying to find out the square only. So we know that in one case, alpha is equal to minus b minus root delta upon 2a. In this case, this becomes equal to beta only because the value of delta is a 0. So you will say that this equation is it a perfect square? Let's see. So the moment you say that this is this, right? Okay, so now when we solve this, we get the answer as 4 root 3 upon 4 into 2, which is just like saying root 3 by 2. So how do I write down the equation? The equation will be written as 4 times of x minus root 3 by 2 into x minus root 3 by 2. So among all these 3 equations that we have solved, these 3 questions, is this a perfect square? No. Is this a perfect square? No. Is this a perfect square? Yes. So when will you get a perfect square? You get a perfect square only when delta is equal to a 0. Otherwise, you can always find out the zeros or the real roots or the imaginary roots. But you get a perfect square only when delta is equal to a 0. Let's move on to subpart 4. So talking about subpart 4, the equation is 2x square plus x plus 4 is equal to a 0. So the value of a here is 2, b here is 1 and c here is 4. Let us find out the value of delta. So delta is equal to a b square minus 4ac, which in this case is 1 minus 4 into 4. How much is 4 into 4? 16 into 2, 32. So this comes out to be a minus 31. So the value of delta means what? Less than 0 means what? Imaginary roots or non-real roots. Or non-real roots. The moment you say non-real roots, you will say non-zero. So this doesn't have a 0. This equation, this quadratic equation doesn't have a 0. Now why do we say this? Because it doesn't have any value of x such that this identity can be established. No real value of x such that this identity can be established. Okay. So now let's see, since we have delta less than 0, let's see, can we make it a perfect square? Let us see. But we know that perfect square can be made only when delta is equal to a 0. So all we can do in this case is we can just write down the values of the roots. That's all that we can do. So we know that alpha is equal to minus b minus root delta upon 2a. So in one case we are getting as minus 1 minus root of minus 31 divided by 4, and the value of beta here is minus b plus root delta upon 2a, which is just like saying minus 1 plus root of minus 31 divided by 4. So is this quadratic equation a perfect square? No, it is not. So let's move on to the next question, which is question number 2. So you will see question number 2 we have already done in question number 1, because I personally feel that when you are trying to find out the nature of the roots, which is determined by the value of delta, you can simultaneously find out the roots as well. So question number 1 and question number 2, incidentally, we have done it in while discussing question number 1 itself. So in that case, we move on to question number 3. So talking about question number 3, subpart 1, it says x minus 1 by x is equal to a 3. For x being a non-zero. And what is the question asking us to do? Find the roots of the following equations. Now again, finding out the whenever you use a word like roots, here you are doing this under the head of a chapter. So you know that roots here means what? You are trying to find out the real roots. But then when you are writing any exam, whether it is any format of an exam, board exam or a competitive exam, the question needs to specify which kind of roots are we finding out. I mean, are we finding out real roots or we are finding out something else? The question needs to specify that. Okay. Now, can I write this as x square minus 1 upon x is equal to a 3, given that x is a non-zero? Yes. Further, I can write it as x square minus 3x minus 1 is equal to a 0. We can just articulate, bring this on the left hand side, and thereafter we could have written. So this is what the equation is, right? So now in this case, the value of a is 1, the value of minus b is 3, the value of c here is minus 1. Let us find out the value of delta. Delta is equal to a b square minus 4ac. So b square here is 9 minus 4ac. So this becomes what? Minus 1 into minus 4 is 4, 4 into 1 is 4. So is delta greater than 0? Yes. So we are basically talking about real roots, right? And we are talking about real roots, unequal roots, which are unequal, and not only unequal, they will be irrational as well. In few minutes we will understand why are they unequal, that you know in any case, because delta needs to be greater than 0 simply for the roots, the real roots being unequal. And then why are they irrational? When we get the roots, we will be able to tell that. So alpha is equal to minus b, which is 3, minus root delta, so minus root of 13 divided by 2a, which is 2, and beta in that case becomes minus b, which is 3, plus root delta upon 2. So which is why we said that the roots are going to be irrational, because in the answer you are getting certain terms which are being written under the head of a root. Let's talk about the next part. So the next part here is 1 divided by x plus 4 minus 1 divided by x minus 7 is equal to 11 by 30, and it is already given that x is not equal to a minus 4 and 7. So what we can do quickly here is we can take the LCM. So once we take the LCM, taking the LCM is just like saying x plus 4 into x minus 7, and then we can write x minus 7 minus x minus 4, in which x gets cancelled out, which is equal to 11 by 30. Now can we rewrite it as this is nothing but minus 11 upon x plus 4 into x minus 7 is equal to 11 by 30, and then we cancel both the sides. So now in this case we can say that it is nothing but x plus 4 into x minus 7 is equal to a minus 30. When we expand this, we get x square. Now minus 7x and plus 4x makes it minus 3x, minus 28 plus 30 is equal to a 0. Then further on we can say x square minus 3x plus 2 is equal to a 0. Right? Quickly now we can find out the value of a, which is 1, minus b, which is equal to a 3, and c, which is equal to a 2. Can we find out the value of delta quickly? Yes, b square minus 4ac, which is just like saying 9 minus 4ac. So minus 8, which is 1. So is delta greater than 0? Yes, that means what? Real roots. It means unequal roots. Now we need to see whether the roots are rational or irrational, for which we know that alpha is equal to minus b minus root delta upon 2a, which is just like saying 3 minus delta is what? 1 divided by 2a. So can I say here I am getting the value as plus 1? Talking about the value of beta, it is nothing but minus b plus root delta upon 2a, which is just like saying 3 plus 1 divided by 2, which is equal to plus 2. So you are getting both the roots as positive and rational. So in addition to this, see what you can do here is when you are finding out the roots, you can start off with real roots or imaginary roots. The next level here is, are the roots equal, unequal? The next level here is, are the roots rational, irrational? And the next level that you can expose this discussion to is talking about the polarity of the roots. So here both the roots are positive. Talking about the earlier question is, so this is negative and this is positive. So you could have talked about one positive root and one negative root.